Measuring the cost of living. The Consumer Price Index, or CPI, measures the typical consumer's cost of living. The basis of cost of living adjustments, or COLAs, as you might have heard them called before, CPI is the basis for the cost of living adjustments, or COLAs, as you may have heard of before, in many contracts and also in Social Security. You may eventually have to ask your employer for a cost of living adjustment to your salary. You can use CPI to illustrate just how much your salary should be adjusted. So this should be a chapter that you're somewhat interested in if you're interested in earning higher salary over time. So let's talk about how CPI is calculated. The first step is, quote unquote, fix the basket. The Bureau of Labor Statistics, the BLS, surveys consumers to determine what's in a typical consumer's shopping basket. Think of a shopping cart. Okay, what are you putting in there? Well, then we find out what we're going to buy, typically, and then we're going to find the prices. So the Bureau of Labor Statistics collects data on the prices of all the goods in our typical basket: milk, eggs, bread, things, cereal, things you all put into your shopping carts. Okay. Thirdly, we compute the basket's cost. We use the prices to compute the total cost of the basket. What's our basket of goods that we like to get actually costing us? Next, we choose a base year, like we talked about in the previous chapter, and compute the index. The CPI in any equal year equals the cost of the basket in the current year over the cost of the basket in a base year in percentage terms, so we multiply it by 100. So again, the cost of the basket in the current year, what it took you to put your items in that basket today, versus what it took you to put those items in your basket and buy them last year or 10 years ago, whatever the base year is. Lastly, we compute the inflation rate, the percentage change in CPI from the preceding period. The inflation rate is the CPI this year minus the CPI last year divided by the CPI last year. So everything's in terms of the previous year. So this year minus last year divided by last year, put in percentage terms when we multiply by 100. Now, let's do an example to help make this thing a little more apparent, hopefully. We have 3 years, 2010, 2011, 2012. We have two items, pizza and lattes. Okay, we have different prices for those years. $10 in 2010, and it went up to $11 in 2011, $12 in 2012. The latte went from $2 to $2.50 to $3. Now, let's assume these are the things you put in your basket: 4 pizzas and 10 lattes. Make up your basket. Now, in real terms, the BLS does a calculation on a much broader range of items. Now, the cost of the basket then, if these are the two things you're putting in your basket, are $10 times the 4 pizzas and $2 times the 10 lattes, $60. Okay, that's the cost to buy what you want to buy, 4 pizzas and 10 lattes this year in 2010. Now, in 2011, it's $11 times 4 and $2.50 times 10, $69. Cost has gone up. Basket costs you more. 2012, $12 times the 4 pizzas and $3 times the 10 lattes for a total of $78. All right. Now, we can compute CPI in each year and get the inflation rate. And here, an example, we're using the base year, or using 2010 as the base year. Okay. Now, in 2010, we take the 100 times 60 over 60 because that's the cost of our basket in the base year and the cost of our basket this year. We get 100. Okay. 2011, cost of the basket is $69 and the base year was 60. Again, we're using 2010 here as the base year. We get 115, multiply it by 100, put it in percentage terms. And then lastly, we use the base year again of 60, and the current year for from 2012 is $78. Okay, from this. So $78 divided by 60, multiply by 100. Okay, get 130. Well, the difference between 100 and 115 is 15%. The difference between 115 and 130 is 13%. Okay. Now, this could equally be computed by the CPI here. 115, the current year, minus the base year. Okay, actually the previous year. Okay, so 115 minus 100. We're going back to right here. Okay, first calculation we made was here. Second calculation we're making is here. So 115 minus the previous year divided by the previous year times 100 is 15%. So it's another way to calculate that. All right, and the current year 130 right here, calculated here from here. Okay, 130 calculated here, minus the previous years, which is 115. Again, calculated using this, and now we're calculating this, which is the same as this. Okay, 130 minus 115 divided by 115. So the previous year divided by the previous year. The current year minus the previous year divided by the previous year to put into percentage terms. So the change from year to year, from 2010 to 2011, is the cost of your basket went up 15%, and the cost of your basket from 2011 to 2012 went up 13%. So that's an example. Let's work a problem. Let's take a look at the CPI basket where we're getting 10 pounds of beef and 20 pounds of chicken. Okay, small basket, we're just buying meat here. All right, 2010, 2011, 2012, we see prices of beef and chicken change. They go up in each year. The CPI basket costs $120 in 2010, which is going to be our base year. So in 2010, to get 10 pounds of beef, we pay $4 per pound, and to get 20 pounds of chicken, we pay $4 per pound, and we get our market basket of beef and chicken costs $120 in 2010, which is going to be our base year. We can compute the CPI for 2011. We can also answer the question of what the CPI inflation rate was from 2011 to 2012. Part A is not all that difficult, but requires an intermediate step. You must compute the cost of the basket in 2011 to find the CPI for 2011. Part B has two intermediate steps: computing the cost of the basket in 2012, and then computing the CPI for 2012. So again, we have two calculations we have to make in that part. Okay. So part A's got multiple steps, but it's a little more simple than part B. So let's get to it. Again, here's our basket: 10 pounds of beef, 20 pounds of chicken. Here's our prices. 2010, the basket costs $120 in the base year. We're going to compute CPI for 2011. The cost of the CPI basket in 2011 is the price, $5, times the pounds of beef we want, 10, plus the price of chicken, $5, times the pounds of chicken we want, 20. It's $150. Now the CPI in 2011, therefore, is the current year divided by the previous year times 100. The CPI score is then 125. Now, in B, same scenario, but we're doing a different calculation here. What is the inflation rate from 2011 to 2012? The cost of the CPI basket in 2012, okay, very simple calculation. The price of beef times the quantity of beef, the price of chicken times the quantity of chicken for that year. We creeped up to $210. Okay, it's going up. CPI in 2012 then is the previous year divided by the base year. Okay, 210 divided by 120 times 100, which is 175. Okay, now we can calculate the CPI inflation rate. Whereas before we had a base rate in the calculation, we didn't have to make the CPI inflation rate calculation. So we have 175, which is the current year, minus 125, which is the previous year, divided by the previous year of 125. Okay, we get a CPI inflation rate of 40%. Okay, that price to get beef and chicken is going up, right? Okay, so if your costs are going up for things you have to buy and say in your market basket, you need to have a corresponding increase in your income to keep up with the market. Otherwise, it's not like you're not getting a raise. If you don't get a raise, you're actually losing money. You're getting a pay cut because the things you want to buy with your wage are actually becoming more expensive. So it's a really important thing to keep your mind on. Now, what's in a real CPI basket? Okay. You can see it broken down here in a pie chart. Food and beverage, housing, apparel, transportation, medical care, recreation, education, and communication, and other goods and services. Each number is the percent of the typical household's total expenditure. For example, 41% spent on housing. Now, I could ask you for examples of how to break down your own expenditures and how it differs perhaps from the typical household shown here. And then I could ask you how a typical elderly person's expenditures might differ from what's shown here. This is relevant because CPI is used to give Social Security cost of living adjustments to the elderly. However, the elderly spend a much larger fraction of their income on medical care, a category in which prices grow faster than CPI grows. The website... The Bureau of Labor Statistics website also gives a very fine disaggregation of each category. So if you wanted to break down a little more about CPI, you could take a look at the Bureau of Labor Statistics, which would enable you to compare your own spending to the individual goods of a typical household. Your spending will change over time. Now, let's take a look at substitution bias. Now, you may understand substitution bias if you work a concrete example like one we're about to work on the slide. Now, before we get started, I might want to get you to consider why households bought different quantities of beef and chicken in 2012 than they did in 2011. Okay, so let's think about that moving forward. Or if that seems too easy, maybe just take a look at the change in relative prices. Beef has become a lot more expensive relative to chicken, so households buy less beef and more chicken, which is sort of intuitive. Now here's our CPI basket again. 10 pounds of beef, 20 pounds of chicken. In 2010 and 2011, households bought the CPI basket. See here, $4 for beef, $4 for chicken. But beef increases from 4 to 5 to 9, chicken increases from 4 to 5 to 6. So beef shot up there in 2012. Now the cost of the CPI basket is $120, $150, and $210. So the cost of the basket is going up each year. Now, in 2012, households bought 5 pounds of beef and 25 pounds of chicken. Why? Well, beef got pretty expensive. So they went down from 10 pounds to 5 pounds and added that other 5 pounds to chicken. It's more affordable. Let's do two things. A, let's compute the cost of the 2012 household basket, and then B, let's compute the percentage increase in the cost of the household basket over 2011 to 2012 and compare the CPI inflation rate. Here we go. Again, same situation. We compute the cost in 2012 of the household basket by multiplying the price times the poundage and adding them together. So $9 times the 5 pounds, because keep in mind in 2012 we shifted to 5 pounds of beef and 25 pounds of chicken. So 9 times 5 plus 6 times 25, and the household basket is $195. So instead of spending the extra 5 pounds on beef, we spent it on chicken, and we went from the cost of the CPI being $210 down to $195. Pretty straightforward calculation. Now, same situation. But we're looking to compute the percentage increase in the cost of the household basket from 2011 to 2012 and compare it to the CPI inflation rate. So the rate of increases, we take the current year 195. Again, they're getting 5 pounds of beef, 25 pounds of chicken, compared to the previous year, which is 150. So 195 minus 150 divided by 150 is 30%. So the rate of increase of prices is 30% increase. CPI inflation rate from the previous problem was 40%. So by shifting from 10 pounds of beef to 5 pounds of beef and shifting from 20 pounds of chicken to 25 pounds of chicken, we lowered our CPI rate of increase by 10%. So which inflation rate, 30 or 40%, do you think more accurately measures the true increase in cost of living in this example? Now, most of you will correctly say 30%. All right, and I could ask you to explain your reasoning and guide you through figuring out what a substitution bias and why it's a problem. Okay, market baskets are always evolving. Price of beef goes up, you eat more chicken. It's a substitution bias. Okay, pretty straightforward. Now, there's some problems with consumer price indexes, CPI. Substitution bias being one of them. Over time, some prices rise faster than others. Different markets, prices change at different rates. Consumers substitute towards goods that become relatively cheaper, I would say inexpensive, mitigating the effects of a price increases. So if beef becomes more expensive, perhaps you eat more chicken. The CPI misses the substitution because it uses a fixed basket of goods. Now, if beef had a prolonged higher price, people would eat less beef. CPI might not necessarily account for that. That is substitution bias. Thus, CPI may overstate the increase in the cost of living, thinking people are eating more beef than they actually are. Now, another problem with CPI is the introduction of new goods. Sometimes you put something in your basket that wasn't in the store the previous time you went there. The introduction of new goods increases variety, which is good for a consumer. It allows consumers to find products that more closely meet their needs. In effect, dollars become more valuable. The CPI misses this effect because it uses a fixed basket of goods from year to year. Thus, the CPI overstates the increases of the cost of living. It might be calculating things on goods that you aren't buying anymore, or missing new and goods that are relatively inexpensive compared to what you were buying. Another problem with CPI is unmeasured quality change. Improvements in the quality of goods in a basket increase the value of each dollar. The Bureau of Labor Statistics, BLS, tries to account for quality changes, but probably misses some, as quality is hard to measure. Just like it is hard to try to centrally plan an economy, it's hard to try to centrally understand an economy. Things are constantly moving, constantly changing. Quality changes for different goods. It gets better, it gets worse. That affects what you put in your market basket. Thus, CPI overstates the increases in the cost of living. Okay? So CPI tends to overshoot things we're seeing here. Each of these problems causes CPI to overstate the cost of living increases. The Bureau of Labor Statistics has made technical adjustments, but CPI probably still overstates inflation by about 0.5% per year. Okay? So if they say it's 21%, perhaps it's more like 20.5%. This is important because Social Security payments in many contracts have cost of living adjustments tied to the CPI. Okay, so if it's overstating the increase in inflation, okay, the overstating inflation, it may cause the cost of living adjustment to be overstated as well. In the 1990s, it was estimated that CPI's bias towards cost taxpayers $1 trillion with a T every 12 years in unnecessary cost of living adjustments in Social Security and government pension payments. That's a big number, $1 trillion every 12 years. It's a lot of cash. Think about that. Now, there are two measures of inflation from 1960 to 2013. The red one is the GDP deflator. The CPI is the blue line here. This figure shows the inflation rate, the percentage change of level prices as measured by GDP deflator, and also the consumer price index. Notice that the two measures of inflation generally move together. There are a few years where they diverge a bit. The reasons for this are on the next slide. We're going to talk about this here in a bit. GDP deflator figures we got from the Bureau of Economic Analysis, and CPI we're getting from the Bureau of Labor Statistics from the U.S. Department of Labor. Both series are quarterly, and the inflation rate is calculated as a percentage change from one year to another. The monthly CPI is aggregated into quarters by averaging monthly values, so they kind of put them on the same scale here. So pretty close, but there's some divergences here. Okay, let's talk about those reasons now. Now, contrasting CPI and GDP deflator, imported consumer goods are included in CPI but excluded from GDP deflator. Okay, little apples and oranges there. Capital goods are excluded from CPI but included in the GDP deflator if produced domestically. Okay. The basket, CPI uses a fixed basket, which for all the reasons we talked about before can be overstating of the CPI. Okay, things in the basket may change, and it won't change as quickly as you change what's in your basket. GDP deflator uses baskets of currently produced goods and services. Okay, it's a little more inclusive. This matters if different prices are changing by different amounts. Very dynamic situation, trying to take a static look. Now, active learning exercise part 3. CPI versus the GDP deflator. In each scenario, determine the effects of CPI on the GDP deflator. In scenario 1, Starbucks raises the prices of Frappuccinos. In part B, the heavy equipment manufacturer Caterpillar raises the price of the industrial tractors it manufactures at its Illinois factory. In part C, Armani raises the price of Italian jeans it sells in the U.S. Okay, these have a plethora of potential effects on the market, but they also change CPI and GDP. All right, so maybe take a moment, think about those, and then we'll proceed to the next slide. Now, if Starbucks raises its price of Frappuccinos, CPI and GDP deflator both rise. Okay, they're both consumption items, so consumer prices are going up. The consumption aspect of GDP is going up. Now, if Caterpillar raises the price of industrial tractors it manufactures at its Illinois factory, the GDP deflator rises because they look at that as inventory, as an investment in inventory. But the CPI does not account for a Caterpillar tractor. Okay, it accounts for the market basket. It's hard to fit a Caterpillar tractor into a market basket. Armani raises the price of Italian jeans it sells in the U.S. CPI will account for this because it's looking at the consumer price index. It's looking at the price of things like Armani jeans and American retailers. Okay, GDP, there's nowhere to put that. Okay, it's either they can already have Armani jeans in stock, they could have sold them, so it would be consumption. But the deflator is not going to account for the fact that Armani just rose the prices unless they actually sell them. Okay. So again, in A, Frappuccinos are produced in the U.S., so their prices are part of GDP deflator. They are purchased by consumers, so their prices are part of CPI. Hence, an increase in the price of Frappuccinos caused both CPI and GDP deflator to increase. Part B, since the tractors are produced here in the U.S., the price increase causes GDP deflator to rise. However, industrial tractors are a capital good and not a consumer good, so CPI is unaffected. It's a capital, not consumer. Part C, Italian jeans appear in the U.S. consumer's shopping basket, and hence their increase in their price caused CPI to rise. However, the GDP deflator is unchanged because it only includes prices of domestically produced goods and excludes the prices of imports. So, in some cases, CPI and GDP deflator count the same thing. In some cases, GDP counts it and CPI does not. In some cases, CPI will count it and GDP deflator will not. So it's two very different measures trying to get at similar items. One is looking at how prices rise, and the other one is looking at how an economy is performing, how the economy has income from all of its goods and services. So let's start correcting for variables for inflation. We can compare dollar figures from different times. Inflation makes it harder to compare dollar amounts from different times. For example, the minimum wage in December of 1963 was $1.25 an hour. In December 2013, it was $7.25 an hour. Big difference there. Well, did the minimum wage have more purchasing power in December 1963 or December 2013? To compare, use the CPI to convert 1963 figures into 2013 dollars. Okay, so we can compare apples to apples. You might be surprised. Now, continue with correcting the variables for inflation. Let's compare dollar figures from different times. The amount in today's dollars equals the amount in year T, whatever year dollars, times the price level today divided by the price level in year T. Essentially, you're converting everything to the amount of today's dollars, so you can compare apples and apples. In our example, year T is 12 divided by 1963. Okay. Today is December 1963. Today is 12, let's say today, the more modern data that we have, let's say today is 12 December 2013. The minimum wage was $1.25 in year T, which is 1963. The CPI was 30.9 in year T. The CPI is 234.6 today. Okay. The minimum wage in 1963 was $9.49 in 2013 dollars. Okay. We get this by taking the two CPIs, price level today, 234.6, divided by the price level in year T, 1963 of 30.9, multiplied by the dollar figure we're trying to convert. Okay. We get that the minimum wage in 1963 was $9.49 in today's dollars. Okay. Suddenly, $1.25 in 1963 sounds pretty good, yeah? Now, comparing dollar figures from different times continued. Researchers, business analysts, and policymakers often use this technique to convert a time series of current dollar nominal figures into constant dollar real figures. Okay. Now, those people can see how a variable has changed over time after correcting for inflation. Example, the minimum wage. It's actually gone down in real terms from 1963 to 2013. Now, that's somewhat interesting. So let's take a graph and look at something over the long run. The U.S. minimum wage in current dollars in today's dollars, 1960 through 2013. Now, the sawtooth pattern of the real minimum wage series arises because the nominal minimum wage is raised. Then it remains constant until it's raised again. So during the time between the minimum wage hikes, inflation erodes and purchasing power erodes the purchasing power of minimum wage. So slowly your dollars can buy less and less and less in your market basket. The long-run trend in real minimum wage is rising during the 1960s and then begins to a long, slow fall from the 1970s to the mid-2000s. A series of increases in the late 2000s lift the real minimum wage, but as of December 2010, the real minimum wage is still lower than it was in the 1960s to the early 1980s. Pretty interesting stuff here. Okay. Pretty interesting. Current dollars continue to rise, but you can see an overall trend in 2013 dollars. If you did an average, put a line across this as an average, it's actually higher back in the day and lower nowadays. Okay. If you look at an overall trend, it's somewhat downward. If you look at it in current dollars, it looks like it just climbed. But if you look at it in terms of what you can actually buy, it's actually either flat or slightly negative. Interesting. Now, let's compare tuition increases. Yay. Tuition and fees at U.S. colleges and universities, 1990 versus 2013. Private nonprofit four-year universities in 1990 was $9,300 in nominal terms versus 2013, which is $30,000. Public four-year, so you have a public university, $1,900 versus $8,800. Public two-year, $906 versus $3,200. Now the CPI here is 130.7 and 232.6. Okay, so we capture that growth in price with the CPI. Now, to express the 1990 tuition figures in 2013 dollars, we must then compute the percentage increase in real terms for all three types of schools. Now let's see here. Which type experienced the largest increase in real tuition costs? Okay, we're cutting through the you-know-what here. We're taking nominal terms and converting it to real terms. Let's see what happens. Now, we know the CPI over that period in 1990 was 130.7. We've seen how to calculate that earlier in this presentation. And we know that the CPI for 2013 was 232.6. That's a 78% change from 130 to 232.6. Okay. Now, again, we have our cost here for a private nonprofit four-year, our nominal cost. Well, what we're seeing here, private nonprofit four-year, $2010. We're using 2010 here as our baseline. Is actually 1990 would be more like a little over $16,000 versus $30,000. Okay. Public four-year current money versus real money. So the 1990s is not as low as we think. Okay. 33, I must call it 3,400 versus 8,800. Okay. So that's 161% increase. And then public two-year 906, which is in today's dollars more like 1,600 versus 3,264, which is a 100% increase. If the prices in 1990 were as high as they were in 2013, the average private four-year college would have cost $16,622. The average four-year public school would have cost $3,396, and the average public two-year college would have cost $1,612. The category with the largest real increase is public four-year colleges and university. It's actually data from the Bureau of Labor Statistics. So indexation, a dollar amount is indexed for inflation if it is automatically corrected for inflation by law or by contract. Okay, so the government can require by law that you index. You control for inflation with what you report. Okay. For example, the increase in CPI automatically determines the cost of living adjustments in many multi-year labor contracts. Okay, so negotiated labor contracts between an individual and an employer or a labor union and an employer. CPI automatically determines also the adjustments in Social Security payments and federal income brackets, okay, which is interesting given the criticisms that we highlighted previously, in that the elderly may spend their dollars much differently than the average American family. Real versus nominal interest rates. The nominal interest rate, again, is the interest rate not corrected for inflation. As we discussed in the previous chapter, the rate of growth in dollar value of a deposit or debt. Okay, so nominal interest rates, how much you're getting interest on what you put into the bank as a deposit, or what you're paying on your credit card in terms of interest rate debt. The real interest rate, the real deal real interest rate is corrected for inflation. The rate of growth in purchasing power it's also the rate of growth in a purchasing power of a deposit or a debt. So it's how much money you got in the bank. What can you buy with that? Okay. How much you can buy with your debt on your credit card. All right. Real interest rate then is the nominal interest rate minus the inflation rate. Okay. So nominal interest rate is just whatever the named interest rate is for today, tomorrow, next week, next year, 10 years from now. And the real interest rate is that nominal interest rate minus the inflation rate. Now, continue to look at real versus nominal interest rates. Let's take an example. Let's say a deposit of $1,000 for a year. Okay, nominal interest rate is 9%. During that year, inflation is 3.5%. The real interest rate is the nominal interest rate minus inflation. Okay. See, when you go to the bank and they want to tell you invest in something, they say, hey, it's great, it's got 9%, but they don't tell you about what inflation is going to do to that 9%. Well, 9% minus 3.5% is 5.5%. Congratulations. Your interest rate that you're getting now on your $1,000 deposit is actually 5.5%. The purchasing power of a $1,000 deposit has grown 5.5%, not necessarily at 9% you thought it would. So inflation matters. Now, this graph replicates figure 3 from this chapter. The nominal interest rate is the rate on a 3-month treasury bill. Okay, so we're looking at real and nominal interest rates in U.S. from 1950 to 2013. The real interest rate is the rate minus the inflation rate as measured by the percentage change in the CPI. Notice that the nominal and real interest rates often do not move together due to variation in the inflation rate. Okay. Again, notice the nominal and real interest rates often do not move together due to the variation in the inflation rate. The inflation rate changes wildly or changes greatly. The nominal is going to be further apart from the real interest rate. Okay. So everybody's selling, hey man, look at these great interest rates way up here. But in real terms, it's way down here. See how that works? Serious inflation difference here. So, in summary, the Consumer Price Index is a measure of the cost of living. The CPI tracks down the cost of the typical consumer's basket of goods and services. The CPI is used to make cost of living adjustments and to correct economic variables for the effects of inflation. The real interest rate is corrected for inflation, is computed by subtracting the inflation rate from the nominal interest rate. So, interesting chapter to learn more about Consumer Price Index. Taking a look at this chapter, measuring the cost of living, CPI, and the previous chapter where we looked at measuring a nation's income with GDP and the GDP deflator, are excellent complements to each other when we consider macroeconomic aspects of the economy. So if you have any questions, feel free to drop by during office hours, give me a call or send me an email. Thanks so much.